Quakes and volcanoes. Starting with volcanoes. What is it? Who knows? Hopefully you know that it kind of looks like a mountain. And it actually has an opening at the top part. And it opens downward to a pool of molten rock, which most of us call magma and lava. When the pressure builds up underneath the surface of this volcano, the eruption actually occurs. And gases and pieces of rock shoot up through the opening and the lava fills up. So if you look at the picture, I'm assuming this is the mom rock. You can see that the calderas here, the opening looks clean and it doesn't have rock. And then this guy Timmy is blowing up because he's under a lot of pressure. So here's a composite volcano. This is where the ash comes out of the top and layers of rock and debris build up over time. So eruptions can happen laterally, which means they happen up and down, like latitudes. They can also happen outwards. When the lava blows and ash flows out through the top, these can cause mudslides, which is usually just mud moving really quickly down the mountain. It can cause avalanches of rock and then flash floods. Because if you look at the picture to the right, the sudden upswell of heat causes thunderstorms to happen. The shaking, the eruption, can actually cause tsunamis and earthquakes to happen as well. So there are roughly 1,500 active volcanoes on our planet. We currently know that 80, close to 85 now, are under the ocean. And these are like not just the little tiny like blips. These are the big oceans. And then the most active volcanoes in the U.S. are found in Hawaii and Alaska, California, Oregon, and Washington. So these are along that west coast of our continent, of our country. So there's three main types of them. There is a shield volcano, which kind of looks like the shield that a warrior would use. There's a cinder cone volcano, and if you look, it kind of looks like a funnel cone. And then there's the composite volcano, which is the very steep sides of them. So then let's look at the cinder cone volcanoes. These are mostly made of cinders, which are basically burnt rock and ash and debris that have been blown up into the air and then settled down. So these cinder cones tend to look very smooth. If you look here, it's a very smooth picture. And they have a very narrow baseline. So that means the bottom of them is really short compared to most mountain ranges above it. And the sides are really, really steep. The shield volcano is long base and low top. So there's a picture of it. Composite volcanoes, this is the big danger, Will Robinson one that erupted in Pompeii or Mount Vesuvius. When these guys erupt, because there's so much pieces to it, it's not just one type of rock, it's layered rocks and particles and ash and different pieces and sometimes big boulders. So when these guys erupt, they throw huge amounts of debris up into the air. So Mount Vesuvius is our big shield that we talked about. And that's kind of our composite. That's the sort of kind of artist rendition of what it looked like as it would have erupted next to Pompeii. When it erupted, it destroyed the entire town, the entire city, along with most of the cities around it. The people, if you look in this picture, were kind of almost frozen in time because as the ash and debris fell, it covered the people, and because it got into their lungs, it turned their lungs into basic concrete. So they couldn't breathe. It suffocated them. When they're found, like as geologists have gone back and excavated to see what happened, they found people huddled together, some people even like cooking at their stoves, and some asleep in their beds. So this wasn't something that they could have prepared for. It happened very, very quickly. So volcanoes around the world, they are located around the Pacific Ocean. If you watched the video about plate tectonics, these are mostly areas of subduction. because they're ocean to continent. So if you look here, it comes up along Alaska, down along the coasts of California and Washington, down the strip of Mexico, and then down parts of Peru and Chile. And then if you look on the other side of our planet, it goes close to Japan and parts of Sri Lanka and India, and then the Sumatran Islands here. So it's not a full circle, but it's kind of sort of a circle. The red dots are active volcanoes. The green dots are volcanoes that were active but are mainly just plate movements now. There's not actual volcanoes, but you can see all these dots represent either an active volcano or a dormant volcano. The Pacific Ring of Fire, the one that was in the picture 2 before, is where there's roughly 450 volcanoes located. It is home to more than half of the world's active and dormant volcanoes. And 90% of the earthquakes happen here. 81% of them, these are a lot of numbers, 81% of the world's largest earthquakes have occurred in this realm of this part of the world. So this is not something that is just looked upon like some easy piece. So just to give you an idea, this is the Peru-Chile Trench that we talked about with the Andes Mountains. They're right on the cusp of this orange and yellow line. The Andalusian Trench is a very deep trench that runs from the tip of Alaska all the way over to Russia. And then here's the Marianas Trench. So you can see these are where huge earthquakes and lots of volcanoes happen. So knowing the lingo or the words, the verbiage, magma is inside the volcano or inside the earth. Lava is when it comes outside. An active volcano means that it erupts regularly. Dormant volcanoes means that it hasn't really done anything for a while. Extinct means that it is either no longer active or it hasn't been active for most of recorded history. Geysers are water that shoot up. They kind of look like a volcano, but they're just water and high amounts of pressurized air. And then ash are the little bits, the fragments of rock and lava that get blown into the atmosphere. Pumice is a light-colored rock that has little holes in it, and they're actually bubbles or gas that got trapped in the rock, and then as it got to the surface, the air pockets popped. So the earthquake zones, the big ones are the Ring of Fire, we just talked about. The Mediterranean zone, this would be mainly the Mediterranean Ocean, near Asia and into India. And then the Mid-Atlantic Ridge zone. So this is that Mid-Atlantic Ridge that we talked about in the notes the other day. And there's not really volcanoes at this point. We're looking more at earthquakes, although there are some volcanoes up in Iceland. So let's look at earthquakes. Yes, these are really real pictures. They're not documented and changed into anything. So this is a freeway, and you can see that the freeway kind of all tilted to the right. So let's look at some pictures. An earthquake is a shaking or trembling of 2 plates and their sudden release of energy. So this is sort of called, most of the time anyway, called faulting. We usually just refer to it as a fault. We don't call it faulting. So we would say there's a fault over there. Parts of the quake, there's the epicenter, which is the surface. The focus, which is deep in the ground where the tension was released at. Seismic waves are the movement of energy, and then the actual fault line. So the epicenter is on the surface. Again, this is where it's felt during the quake. It's usually the most violent part because it's on the surface, so that's what we see. It's what we feel. The focus is beneath. This is where the rocks break and move. It's the origin of the earthquake. The seismic waves, we're not going to spend too much time on this, but there are 3 types, primary, secondary, and surface. The surface, obviously, are the ones we feel. I'm going to skip this. If you want to pause it and read, you can. The 3 types of faults, there's a strike slip, which is where the earth is pushed apart, and it's pushed in like north and south directions. Like the ground doesn't fall or rise, it just moves apart. The normal tension is where one piece is pushed upwards, and then a reverse is obviously when the focal point is pushed down. So if the epicenter moves up, then it would be a normal. If the epicenter moves down, then it would be a reverse. The San Andreas, we talked about this the other day, is 960 kilometers from Mexico to the northern part of California. This is where the land is actually moving to the west of the fault line is moving northwards, and the land to the east of the fault line is moving south. So San Francisco, if you look at the map, San Francisco would be moving south, and Los Angeles would be moving north. So the San Francisco quake, this is one of the big quakes that we study. If you look at the building, the one on the left is before the earthquake, and the one on the right is after the earthquake. So this earthquake, and there are multiple in San Francisco that happened. There's the 1906 and then the 1956. You will be asked to look at one of those and do some research. If it's an earthquake that happens on the ocean floor, these are called tsunamis. They move wicked fast, and they can reach the coast and be higher than 20 meters. This is not, I repeat, this is not a real picture. This is a photoshopped picture. But it's to try to give you an emphasis on what could happen in a densely populated area. There was a tsunami in 2005 along Sri Lanka, and something like this, the pagodas or the houses were not that tall, but there were people standing that close to the shore and busy areas, and they got swept out to sea because these things move 800 miles or kilometers an hour. The seismograph is how they're measured. The weighted spring moves around and measures how the earth moves. So that's a picture of what a seismograph's imaging would look like. There's this thing called the Richter Scale, and this is the amount of damage that was done by the earthquake. So a 1 would be like you barely even knew it was happening. We've had a 3 in North Texas area before, and there's even been a 5 out in West Texas. So Texas isn't as still as we would like to think. But the 10s and the 9s, those are really intense. When we go to the Perot, they let you sit on a machine and you feel what a 9, I think a 9.7 feels like. So the earthquake damages, obviously these are not easy things. They are very damaging to the infrastructure of a city. Sometimes they even move the picture on the left makes me giggle. But if a railroad car were to go down this, it would actually throw the train off track. But it can move things that seem very still and solid. And then the picture to the right is one of the devastating pictures after the Japanese earthquake in 2011. So these are intense environmental damages. And then they can actually damage things out in the ocean water, which causes environmental impact. If you look at the picture on the right, this is a telephone tower that fell and then is now releasing radio waves out into the water. So I hope this helps clear stuff up. I'm not meaning to end on a downer, but these are some things that you will have to research, so feel free to come back and pause and look at things to include in your PowerPoints and your presentations. So I'll see you in the halls.